Okay, we are solving specimen paper 2023 physics paper. That's paper 6. What we are reading over here in the question is a student investigates how partly covering the top of the beaker of water affects the rate at which the water cools. So you can see this the beaker is over here. Okay. Then partly covering, it means some part of it is being covered over here. Okay. A thermometer is there which is going to note down the change in temperature. It means depending upon at what distance we are going to keep this, how much we are going to cover this, depending upon that, the fall in temperature is going to be there. More the cover you keep, it will be difficult for water to cool down and the temperature fall is going to be slower. This is one concept that you have to keep in mind. The next part that is there is first, of course, this is the reading that we are supposed to take. This is a thermometer given. We can zoom in and we can take the reading. Okay, you can see over here, I have zoomed in a lot. The temperature, how much is the temperature? Just read the temperature.
21.
Correct. The temperature is 21 degrees Celsius. That temperature, I'm going to write that down later. So this temperature is 21 degrees Celsius. This is the initial temperature. See, we are reading the next part of the question. The student pours 100 centimeter cube of water into the beaker. Okay, 100 cm cube of water is kept into the beaker. She places the lid A in the beaker. We will see where this lid is. This is lid A. This leaves half of the top of the beaker uncovered. So it means this part is going to be half, as shown in figure 1.3. The next part, she records the temperature of the water in the beaker and immediately starts the stopwatch. She will record the temperature theta of water every 30 seconds. Here the readings are shown in the table 1.1. We will see that table also. Then we have that second lid B. This leaves the quarter of the top of the beak uncovered. It means this much part is covered. And this part which is there is the uncovered area. So obviously here the uncovered area is less. Therefore, in lid B, where second lid will be used, the slowing down, the falling of temperature is going to be slower. Obviously, we'll just go through the table. Okay. T, we are supposed to write down over here the units. We are supposed to fill this up. This is going to be in seconds. This is going to be degrees Celsius. Okay. Obviously, every 30 seconds we are taking the reading. So this is, you can easily fill this up. 30, 60, 90, 120, 150, 180. Okay. So this is the way we are going to fill up the table. Let's see what's the next part that they have asked. Describe the precaution that should be taken to ensure the temperature readings are as accurate as possible. What should be the precaution that we are going to take? Here, this is our experimental setup of the apparatus. What is the precaution that we are going to keep? See, for both readings, one thing that important that we can note is this level of thermometer. Whenever we are keeping lid A and lid B, two different parts, this level of thermometer which is there, it should be at the same level. It should not happen that in one case the level of thermometer is this and in another case the level of thermometer is this. Okay. So this level of thermometer which is there, it should be same. It should be same. That is the precaution. All right. That's the precaution. I have noted. I am been recording this class. So afterwards, whenever you want, you can again refer to it. I will upload it and send you this video. Write a conclusion to this experiment. stating for which lid the rate of cooling is greater. Justify your answer with reference to the result. So we will just note down the readings. Okay, for lid A, you can just check the temperatures, fall in temperatures 80, 77, 74, 81, 79, 77.7, 77.5. This is 72.5. You can see over here the fall in temperature which is there is approximately 3 degrees Celsius. Here the fall in temperature which is there is 2 degrees Celsius. Here the fall in temperature which is there is 2.5. Here the fall in temperature which is there is nearly 1.5. So you can see here there is lesser fall in temperature. Here there is quicker fall. What is the reason behind this? Because here this is half lid open and this is 1/4 lid open. Here only this much part was open. Here half the part of this was open. So the rate of evaporation will be faster. If the rate of evaporation is faster, rate of cooling also is going to be faster. That is the justification that we can give, that in beaker A, beaker with lid A, the fall in temperature is quicker. Reasoning, the lid is half open and half closed, compared to B, where the fall in temperature is lesser. Reasoning, here only 1/4 of the lid is open. Afterwards, when you are going to revise this, you will just revise this again and again. So that was the experiment. The second part of the question: suggest a change to the apparatus that produces greater difference between the rates of cooling for lid A and lid B. Now, what change we are going to make so that the difference in rates will become bigger? Explain why this change produces greater difference. What change we are going to produce and what will be the explanation for this? What change we are going to produce so that the difference in temperatures between both of these lid A and lid B is bigger. In one case, what you can do is, okay, in case of lid A, if you are using, the fall is faster. When you are using lid B, the fall is slower. What I can do is I can cover the thermometer with lamp black. If you cover it with black, it will radiate out, it will give out heat faster. So you cover this thing with lamp black. What is the reason? First is what we have done, covering when we are using lid A, cover it with lamp black. Reasoning or explanation, what is going to be there? Black color radiates heat at a faster rate. So the difference in changes in temperature between lid A and lid B will be greater. Okay. Just now, I have just explained you all of these things. Afterwards, you need to revise this and then you have to write all these parts down. Okay. The E part of the question. Another student thinks that the cooling rate is directly proportional to the percentage of surface area uncovered. Percentage of area uncovered. We draw the graph of cooling rate against the percentage of uncovered area to investigate this. Describe how this graph line shows whether the rate of cooling and percentage of uncovered surface area are directly proportional. This graph has to be a straight line. The graph should be somewhat like this. The rate of cooling will be faster if the surface of uncovered area is bigger. Students in other countries are doing the same experiment. State one factor they must keep the same to obtain the similar readings. What factor should be kept same? They are doing the experiment in a different country. Now in different countries the temperature will be different. So we will have to use a device that is called a thermostat. Thermostat is a device, it is a box in which whatever the contents are there, the temperature is not allowed to change. Either you can use this, or what you can do is, other thing that you can do is you can keep the size of the beaker and the thermometer which is used, that should be kept same. This is an important factor to obtain similar readings. This is a blank page. Okay, we have to read and record the readings of voltmeter and ammeter, that is IV and I. Okay, we'll just zoom in and do it. First, I'm taking the reading of V. Can you tell me how much is the reading of voltmeter reading V? The pointer is here. This is the pointer. How much is the reading? You just count how many steps are from year to year. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is coming on the sixth step, so this reading is going to be 2.6 volts. Did you understand that part? Are you able to hear me?
Yes, sir.
Okay.
Yeah.
So
Yes,
six
sir.
step is coming and total 10 part there, sir. So the voltmeter reading is going to be 2.6 volts. You should also know all the units properly. Afterwards, I'll give you one sheet in which all the units are going to be there. Now we'll take this reading. Let's see from here to here, how many steps are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0.2 is divided by 10. It means every step is going to be 0.02 amperes if I divide this. So after 0.02, you just keep on adding 0.02 over here. This is 0.2, 1, 2, 3, 4, 5, 6, 7, 8. 8 steps of 0.02 I have added. Already here this 0.02 is there. Sorry, 0.2 is there. Plus 8 steps of 0.02. This is going to become 8 multiplied by 2, 16, that is 0.16. So this we will add 0.16. This reading is going to become 0.36 amperes. I'm going to do the explanation once again. Okay. What I have done over here to take the readings. From year to year, how many steps are there you are going to count? There are total 10 steps are there. Okay. Total from year to year, it is 0.2. If I divide this by 10, it becomes 0.02. So every step is 0.02 amperes. Now from 0.2, from this point I count how many steps are there? 1, 2, 3, 4, 5, 6, 7, 8. I'm reaching up till the pointer up on the 8th step. So 8 multiplied by 0.02 and plus original this 0.2 is also there. If I'm adding this, okay, I'm getting 0.36 amperes. I've explained to you twice. Go through this recorded video very carefully. Okay, I have put all the readings. Okay, that is being taken. The student then connects the crocodile clips to the length L is equal to 60 centimeter, 40 centimeter of the resistance wire. It means this is the length through which the current will pass. She measures the potential difference V across the terminals P and Q and the current I in the circuit. The readings are shown in the table. Okay, the table is there. We have to fill up a few things in the table. Length centimeter is already given. V, this will be volts, or simply you can write capital V. I, the current will be, the unit is amperes. So I'm going to write A, or I can write the full thing amperes. Okay. Now V and I, these readings we have already taken. This was 0.36 amperes and this was 2.6 volts. We just have to calculate R, that is ohms, and R upon L. Okay. So R, how we are going to calculate? The formula is R is equal to V divided by I. You'll have to use your calculator. V divided by I. So in this case, it is going to become 2.6 divided by 0.36. We'll do all calculations together. This is going to become 2.5 divided by 0.49. The last calculation, 2.3 divided by 0.74. We are going to write down all these three readings. Another student suggests that the values of R upon L for each of the lens wire should be the same. We have seen that here slight difference in values are there. State whether the results suppose this suggestion. Justify your statement with reference to the values from the result. Statement and justification. Okay. The values in fact that we have got are 0.080, 0.078 and 0.077. These values are very close to each other within the limits of experimental error. There may be some little differences in experimental readings that are taken. So these values are correct. We will say that. So the statement is, okay, these values are almost the same. Justification is the values 0.080, 0.078, 0.077 are close enough within the limits of experimental error. Okay, we have finished this question. Suggest one difficulty which explains why different students doing experiment carefully with the same equipment may not obtain identical result. Now why everybody, all students may not get the same result or similar result? Simple reason for that is it is difficult for every student to attach the crocodile clip at the same place. Afterwards, I will give you all the list of apparatus, what is the meaning of this crocodile clip and everything. This part also I will send it to you. It is difficult for every student to attach the crocodile clips at the same point. Okay, that's the reason. A student finds that during the experiment, the wire becomes hot because there is high current. He decides to use a variable resistor to prevent this. Draw an X on the circuit in figure 2.1 to show the variable resistor that is connected for the purpose in this experiment. You should know these diagrams. I will give you all the electrical circuit diagrams. Circuit symbol for variable resistor. This is going to be the circuit symbol for variable resistor. Okay, you can simply draw like this and you can put an arrow this way. This is the circuit symbol for variable resistor. Okay, this is the last question now we are doing, that is planning an experiment. This kind of questions are going to be very important. Okay, you will have to think on your own and do. We will do maximum practice of these kind of questions of planning an experiment. There is one full one video is there of 2 hours, which I have recorded before, of planning an experiment. Okay, let's see what this experiment tells us. A student is investigating the factors which affect the size of crater, the hole a ball makes when it is dropped into the sand. So here you are going to have a bowl of sand, and depending upon, suppose if the ball size is this much, how much big hole it is will make. The ball size is this much, how much big hole it is going to make. The ball size is this much, how bigger hole this is going to make. Obviously, the smaller ball is going to make a smaller hole. That is understood. Plan an experiment to investigate one factor that affects the size of the crater. Okay. Now the apparatus available includes metal balls of different sizes, a tray of sand. Write a plan for the experiment. In your plan, you should state which factor is being investigated. State the key variable that is supposed to be kept constant. I'll explain you this. This is a very easy experiment. Then list any additional apparatus needed. Explain briefly how the experiment, including what is measured and how this is done. State how to obtain the reliable result for these experiments. Suggest a suitable graph to be drawn from these results. You may draw the diagram if it helps to explain your plan. We will draw the diagram. Whenever you draw the diagram, half of your efforts are reduced. Obviously, we are going to plan an investigation. I have already shown you that diagram also. Okay. We are going to have a sand bowl. Different sizes. Suppose here, this is metal ball 1. This is metal ball 2. Obviously, all of them will be dropped at the center only. I'm not dropping at different places. This is metal ball 3. This is metal ball 4. Okay, 1, 2, 3, 4. 4 different sizes of metal balls. We are going to measure the diameter of the ball, and then we are going to drop it. Once it is dropped, is going to make a hole. We are going to measure that distance. Now, how we are going to measure that distance? For that, we are going to need a scale. One more factor that is supposed to be kept constant. All of the balls should be dropped from the same height. This is the factor that is supposed to be kept constant. This is very, very important. The height from which every ball is dropped should be same. This scale which is there, obviously it is going to measure how big that ball has formed that circle. The last part that is remaining to be explained is how you are going to plot the graph. Obviously, here we will write the graph for this. Okay. Whole I'm going to write over here. And the diameter of the balls I'm going to consider here on the x-axis. The diameter of ball are over here. What is the size of the hole? And depending upon whatever the values you get, you are not supposed to plot that graph. This is the graph that you will draw. Hole, you will put it on y-axis, how big the hole is produced by that ball, and the diameter of every ball that you are going to put it on x-axis. I've explained you the full experiment. Try to write this experiment on your own. I have recorded it. I'm going to upload it in some time and I'll send it to you.